Well, good morning, everybody. This is Panama Bartholomew with the Building Decarbonization Coalition, and thank you all for joining us at the Building Decarbonization Coalition Presents webinar series. We got a fantastic one today on the air quality impacts of electrification in California. We're joined by EPRI, who's done this research, and we're going to hear from Marcus in a second going through that. We are really excited that you're joining the webinar series. We have a lot more webinars planned that we'll be talking about in a second. You are all muted upon entry, and so you can't talk yet, but we're going to give you the opportunity to be able to ask questions via the chat. We have over 80 people registered for this webinar, so it's not really, it doesn't lend itself well to having people being able to jump in through conversations. So I'll tell you how to ask questions via chat. Just a little bit of background about who we are and what's going on. We're the Building Decarbonization Coalition. We are a coalition of energy utilities, builders, manufacturers, the real estate community, local governments, and non-governmental organizations, all working together to bring about building decarbonization solutions in the policy and market spaces for California and beyond. We have over 140 members that actively take part working together on developing those market and policy solutions. We released a roadmap back in January of this year that really laid out a vision for what California needs to do to decarbonize its buildings if we're going to meet our housing affordability, our public health, and our climate goals. And it laid out a series of goals for California, including that we should be requiring zero emission buildings for both residential and commercial buildings by the end of next decade. They should be required to be zero emissions, that we should be completely eliminating emissions from the built environment by 2045 or sooner, and that we need to dramatically increase the sale of, in particular, heat pump technology to be able to meet these targets. Underpinning all these numerical goals for the coalition were a series of 5 goals that we think are necessary in order to be able to meet our numerical goals. That's really good. Improving awareness among all stakeholders, giving customers, building owners, and occupants a good value from electrification, making sure that builders and installers were getting a good value proposition from it, getting the supply chain ready and the barriers out of the way, and then aligning policy. And this webinar series is really about goals number 1 and 5. Just how do we use the webinar technology and approaches to increase awareness and to also help to drive people towards policy solutions. And so we have, as I mentioned, some great webinars coming up. On August 8th, we're going to be hearing from TRC. That's going to be talking about a study they did for the Building Decarbonization Coalition. They've interviewed a whole series of builders up and down California, market rate, affordable, production, custom, and they're going to be going over the results of that, about what's their opinions of electrification, what are their fears, what do they think is needed for that space. Then on August 15th, we're going to be joined by Richard Young from Frontier Energy, that's going to go over a report that he just completed on behalf of SMUD, looking at the comparison of different cooktop performance, comparing induction cooktops to resistance cooktops, electric resistance to gas cooktops, and spoiler alert, induction's better, significantly better. So join us to hear from Richard on August 15th. And then we're going to be hearing from A.O. Smith about new commercial hot water heating for a small commercial offering that A.O. Smith is just releasing into the market on September 5th. And you can, we'll be sending out announcements for the registration for these future webinars, as well as putting it up on our Building Decarbonization Coalition website about how you can register for these webinars. So please keep coming back to our Building Decarbonization Coalition Presents webinar series. And if you would like to join in with the coalition, have regular updates about what's happening in the marketplace, and then joining other leaders in the marketplace who are actively seeking to bring about some of those changes and make the news, it's very easy to join the coalition. We would welcome you in, buildingdecarb.org/join. You can come in, it's free to join the coalition. You can join 140 other organizations that have come together and are actively working on how to drive this marketplace. So thank you again for joining. I'm going to stop talking and stop sharing, and I'm going to hand it over to Marcus now with EPRI to be able to give our presentation today on the air quality impacts of electrification. So Marcus, take it away.
Great. Can you hear me? Can you hear me? Oh, it looks like you muted yourself, Panama. I guess, can anyone hear me?
I did, but we can definitely hear you. You're coming through loud and clear.
Great. I just wanted to make sure before I launched in. Thank you very much. I appreciate it. So I'm Marcus Alexander. I'm with EPRI, and this presentation is concerning a study that we recently completed with the CEC that was basically looking at the air quality implications of a high electrification scenario. And so, of course, at least from the title, this group is concerned with building decarbonization, and decarbonization is certainly important. But in addition, there's the question of how that affects air quality. So, in general, we expect it to be better since electrification eliminates local emissions. But for better or worse, this stuff gets pretty complicated when you're really looking at air quality, and so that's not necessarily assured. And there's also the question of how we could maximize the benefits of air quality while also achieving decarbonization. So I'm going to, in the presentation, I'm going to cover the background, talk about our scenario, what air quality modeling is to some degree, and what our results were, health effects. One of the focuses of the CEC, and I would imagine many groups are kind of in a similar, many groups on this call are in a similar situation since they're seeking California funding, California state government funding, but there was a particular interest on the effects of on environmental justice communities, so we'll go into that in more detail and then I'll wrap it up. So in terms of background, I'll put the report number later on as well so that you can Google it and find it, but this is the CEC report, basically, blah, 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 49. So what we're looking at is an aggressive electrification scenario. And I'll go into exactly what that means in a bit more detail, but focus on the building side of it. Our part of this was basically figuring out, okay, if we have a high level of decarbonization and we have this kind of aggressive scenario, what does that mean for air quality? And what are the particular results in terms of human health impacts? One of the reasons that this is important, and one of the kind of, let's say, difficulties in doing this is that greenhouse gas emissions are, certainly related to, let's say, general pollutants like NOx in this case, but they're not exactly the same. And so this chart shows from the EPRI, which was produced from the California government, shows the emissions from these different categories in terms of both CO2 and NOx. And so, of course, for air quality, we're also interested in a number of other things, but NOx is a good proxy for effects. But the ordering of the chart basically goes in decreasing order of CO2 from left to right. And then, NOx is kind of shown as a byproduct. So for some of the categories, they're pretty related, but for a lot of them are not. So for instance, for electricity generation, this is a significant source of CO2, but for NOx in particular is not really a big source of emissions. Whereas for medium and heavy duty trucks, for instance, there's a large contribution from NOx, even if the contribution from CO2 is, about 9%. It's not tremendously large. What is that? 6 from the right or 6 from the left is residential fuel consumption. So we'll go into more detail about this, but basically this, is kind of what I've focused the presentation around, as you'll see in a bit. But, it's important both from CO2 and NOx, but it's actually more important from PM 2.5. But in terms of defining our scenario, what we had to do was basically we used an existing, oh yes, sorry. For some reason it blanked out on my side. So what we did is we used a scenario that I'll go into in a second that was from a previous CEC study, and added some assumptions around air quality. And so that had a particular effects on the on this residential side. And in terms of additional background, so for environmental justice, I'm not going to go into this too much here. Environmental justice is basically the idea that, let's say, for instance, you don't have refineries located in Beverly Hills generally. So there's a big income impact in the effects of air quality. And this can be seen in numerous ways in terms of both the what pollution ends up getting allowed in lower income communities, and then also just if you look at the let's say housing prices versus pollution levels, there's a very high correlation and recognition that basically the burden of pollution is generally on lower income communities, and these communities generally have less power to affect change. And so a goal of the California recent legislation and regulation is trying to eliminate or reduce this gap as much as possible. And so we did look at the effect of this on environmental justice communities, and in particular we used the definitions in Cal EnviroScreen 3.0 for those who are kind of familiar in this area, and we'll go into that in more detail. In the full report we have more discussion of implementation in disadvantaged communities, but I don't have that in this presentation. In terms of our scenario, we started with a scenario from a previous study called long-term energy scenarios in California. So, this shows the CEC number if you want to check it out. The particular scenario we used, it came from E3 based on the pathways model. And so, that scenario looked at various ways of meeting California's then goal of, I believe it was an 80% reduction by 2050. And I can't remember now, there's probably 8 different scenarios in that study. And we used one in particular, it was called the, I don't know if I have that here, but anyway, it's not particularly important, but we used one that kind of focused on electrification in the way that we thought it would occur. In general, with this study, I think it, if you go back to that kind of source material and look at it, it does show the challenges, as everyone is aware, in terms of achieving this level of decarbonization. But of course, since that study came out, and since kind of when we were in the final stages of our study, the goals became much more aggressive. So current goal for California is, I believe, electricity being fully decarbonized in 2045, and zero, I think it's, I can't even remember anymore. I guess zero net carbon in 2050. The exact definition of those is, of course, still being decided. But basically, if this was a 10 in terms of difficulty, now we're at 11. So the results from this should be kind of interpreted in that context that this gets us, or the overall scenario in this gets us to a relatively low level, but we're going to have to go even beyond what's in here to really achieve the current goals. In terms of the specifics, I'm going to go through this in a bit more detail. This is the non-transportation assumptions, but given the group, I won't go into too much detail in the next slides, which are more on transportation. But in terms of looking at it kind of economy-wide, study or approach, so buildings are certainly important. I'm sure that someone on this call could tell me what percentage they are, but I know they're a large percentage of overall carbon. But of course, the transportation and electricity generation and other aspects of the economy also end up being important when you're trying to get to low levels, and especially when you're trying to get to zero. In this case, for industrial, we assumed that most, let's say some of the more energy intensive applications like boilers and heat were electrified, but there's an awful lot of stuff that doesn't get electrified in this, in terms of, let's say, chemical manufacturing in particular. Like, we essentially have no data on the electrification potential there, even though we think that there's some. and in terms of solvents and other things, these are important for air quality in particular. Solvents really affect what's called like volatile organic volatile organic compounds, and so have a big effect on air quality. But again, although there's the potential for electrification in those areas, we don't really have enough data to create a specific scenario. So we assumed no electrification in that area. We also didn't electrify things like, of course, fires and roads or particular road dust. So these are basically things that are important from an air quality perspective, but aren't really within the energy sphere and aren't really electrifiable. And then finally, down towards the bottom, in residential, we did assume a relatively large fraction of electrification for this. And this, as I mentioned, this came from that LTES study. So those studies were, or those portions of it were particularly studied in that, but, and so we didn't have to kind of add additional assumptions. But as I mentioned, in order to really reach the goals we're talking about, we're gonna have to go beyond this. But 99% of, basically non-space heating natural gas use was assumed to be electrified, and 83% of space heating. And there's an important one here, which is that we assumed that 100% of wood-fired heating was electrified. And this didn't seem like an important assumption at the time, but it ended up being quite important, as I'll go into. And this is something that I kind of want to focus on for this group, just because I think it may be, although our results are, or let's say no sets of results are definitive, I think that this indicates that this is an area that should be a focus. In terms of non-road transportation, we assumed a lot of electrification for, let's say, lighter, let's say light engines like, well, forklifts can get pretty big, but ground support equipment and lawn and garden. So, basically anything that's kind of a two-stroke, we assumed would be electrified. And then in terms of some of these things like terminal tractors and refrigeration and so on, we assumed a relatively high level of electrification there as well. We didn't assume electrification of rail, and we didn't have, well, I guess, thankfully didn't have California high-speed rail in this study as kind of a modifier on transportation. But even though I think that, there is potential here, and hopefully that will happen in the future, but basically we didn't really have modeling behind it. For on-road transportation, it was basically between about 80 and 90%. And in general, like when we did this, it seemed pretty aggressive. If I were doing it again, since we kind of locked down these assumptions, Tesla, announced their semi-truck and, other, let's say there's been a lot of other activity in medium and heavy duty. So things that we previously thought seemed aggressive now seem pretty possible. But this doesn't end up being as important as you'll see. In terms of the overall emissions inventory, these two charts show the reference scenario on the left and the electrification scenario on the right. And so in terms of the emissions inventory, VOCs did decrease significantly in the categories where electrification was possible, but the green, kind of large patches that you see is basically solvents and other things like that. So basically this is, I don't know, if you go through the inventory, even things like hairspray end up actually being important, but this is, paints and other things like that that are not within the scope of electrification or the energy sphere. In terms of NOx, this is one of the critical pollutants, and we found significant reductions, and basically that's because of transportation and homes to some degree, but mainly due to the transportation side, and to some degree industrial. Similarly for sulfur dioxide, there was significant reductions that basically came from those same areas. And the PM 2.5 ended up being, it looks pretty small in here. If you look, this is the one that's over on the far right, but this ended up being particularly important just because of the high health impacts from particulates. In terms of air quality results, So this chart shows our results for the Southern California basin. So this is basically, it's a little bit hard to see actually. I should have had a map that shows this from a higher level, but the kind of purple area is basically, as you would kind of expect, is the populated area of the Los Angeles basin. So if you look at it from space, that's about the purple area is about what's populated, and that's also about what's polluted. On the left-hand side is the reference scenario, and so this is just our estimate for the emissions levels in 2050 without any changes. On the right is the electrification minus the reference, so it's basically the improvement from electrification. And so the darker blues are the areas that are more highly populated, or sorry, more highly affected or reduced by electrification. And then in this case, there are no areas that have a negative impact from electrification. On top, this is the winter. On the bottom is summer. And what you generally see, which many people don't necessarily expect, is that PM 2.5 has more effect in the winter than it does in the summer. And basically, there's a number of reasons for that, but it's the atmospheric chemistry and so on, and the pollutants. But we'll get into ozone in a second, and that's more of a or that's almost entirely a summer phenomenon. But for PM 2.5, it's more about winter. If we take the contributions that we looked at earlier and break them down into the different sectors, what we find is that on-road and non-road, off-road transportation are important. So those are the left two charts, and those are what people generally think of in terms of reducing emissions. But what we found also, and that was somewhat surprising, is that residential and commercial ends up being quite important. And so this is something that we spent a lot of time digging into, and that, as I mentioned, I think is probably going to be one of the more important results for thinking about building decarbonization. What we found when we kind of dug into everything, and there's a larger explanation on this in the report, or larger kind of investigation, is basically that it came down to residential wood combustion. And this was pretty surprising to us because, as I kind of indicated earlier when we were doing the assumptions for this, looking at it from an energy level, or the way that I've typically kind of approached the system, residential wood combustion is almost negligible. It's a very small fraction of total energy and total households. And so a lot of inventories and studies actually, my take is that they don't even really include this, just because, it's just so small on an energy basis. However, on a pollution basis, it ends up being quite important, or air quality basis, it ends up being important. It's worth noting that when we talk about residential wood combustion, we're talking about burning wood for, what I would call like ornamental purposes, like having a fire at Christmas time, and heat. And one of the questions we've gotten in presenting this is basically how much of this comes from lighting a fire for Christmas time, and how much of this comes from heating. And the unfortunate thing is that we really don't know, because that this is an area that is, let's say, reasonably well studied, but not well studied enough that you can really break things down into that level. But it's worth noting that what it doesn't include, because this question's come up quite a bit, is things like burning, burn piles, and of course, structure fires and other things like that. And actually, since it is important, wildfires end up being included in another category. And that would include, of course, any structures that got caught up in that. But basically, this is purely, like a fireplace in a house, and the combustion that happens in that location. When we look at this from a large scale in terms of the PM 2.5, what we find is that the residential and commercial emissions are basically as important as all other anthropogenic emissions within California. And for the most part, it's a higher effect. And as I mentioned, that this is something that we weren't expecting to see at all. And basically what it comes down to is that even though this activity is pretty small, even though there's basically very few households that have that actually use wood, especially wood for heating, it ends up being very important, and especially in Northern California, presumably generally because there's higher heating need than in Southern California, and in particular, this has a big effect in Sacramento or the Sacramento area, and basically that's because you have both the local emissions from the area, and then also you have the general, kind of, let's say, air shed from the Bay Area. The wind tends to blow, west to east, even if it doesn't happen every day or if it's imperfect. In Southern California, you see a similar thing. Depending on the area, all other anthropogenic can be bigger, but basically, this effect alone is as important as basically everything else we're doing here, including very high levels of transportation electrification. I just wanted to show real quick that that this is not true in summer, and basically that's of course there is some heating in summer. But not much. So essentially that activity goes away. And so all of the water heaters and other things like that, cooking, these are important from other aspects, but in terms of this effect, they're essentially not very important. I think it's worth noting that, we, as I've kind of said in the past, like it's not like we discovered, cold fusion here or something like this. This is relatively well known, and there's already a number of regulations on it. For instance, new houses in the Bay Area cannot have wood-fired appliances or, basically fireplaces. And wood burning is banned on spare the air days. And, in general, there's a lot of policy pressure around trying to reduce the amount of wood burning that goes on. For instance, I've heard that they're looking at putting warnings on firewood or something like that. However, even in these spare the air days, houses without alternative heat sources are allowed to burn wood, and this does happen. This is a significant portion of the total. Like we have trouble quantifying exactly how big of an effect this is, but basically every time I've presented this and asked someone about it, they say like, oh yeah. I have a neighbor who, doesn't have a heater. And the way this is normally defined is not having a natural gas line. And of course, traditionally that made sense. For this group, of course, we'd argue that electricity can also be used for heating. But anyway, this is something that I think is particularly important in terms of thinking about electrification, just because this is an area where we can get multiple benefits from electrification. Of course, carbon is important, but we can also achieve big gains in air quality. It's worth noting, given the context of the presentation, that basically, given this importance, this is known to be important. Why don't we just ban wood combustion in general? Basically, the reason why is that there's a lot of income questions. Of course, there's also everyone wanting to have a fire at Christmas, but there's a significant equity question here, just because wood in general is used because it's the cheapest and best alternative for some customers, and so making sure that that we don't have a heavy or ham-fisted policy that causes significant negative effects is going to be important. In terms of ozone, I won't go into this too much, just because this is mainly about transportation, and given the group, I don't think it's as important. It's worth noting that I'd love to go into this in more detail. I think it's a pretty interesting thing, but there is a negative effect in some areas due to electrification, or a negative ozone effect. And basically what it comes down to is that there's a particular effect called NOx titration that where basically if emissions are high enough, or the concentration levels are high enough, then you actually get a benefit from a certain a certain air chemistry. What it has, massive downstream negative effects, and it has negative effects in other areas. But in terms of ozone, it can actually be a benefit. So by reducing ozone, you can actually, by reducing NOx, you can actually increase the local emissions of ozone. And in general, that's negative, and it would be great if there was a way to make that not happen, but unfortunately, it's just a byproduct. As I'll go into in a second, the benefits of the changes in emissions overwhelm these effects, but it is a negative. In terms of valuing the health effects, what we used is a relatively standard approach. I'm not going to go into this in too much detail, but basically, we used a model from the EPA called BenMap, which looks at, which I guess in some ways, is kind of the I guess the easiest way you can kind of think about it, which is looking at the pollution change, looking at the effect that has on population, looking at the changes that has in the incidence of, in this case, we focused on mortality. So basically deaths due to, the negative effects of air quality, and then used the standardized, value of statistical life in order to turn this into monetized benefits. And it's worth noting that, there's a lot of, we go into the report in some detail on why, I would say, no one really likes assigning a dollar value to, to, let's say, health impacts, but basically this, for various reasons, this is done, or has, let's say to some degree has to be done in order to quantify what the benefits of the changes that we're seeing. In terms of these benefits, what we see is widespread benefits from PM 2.5. I think, I'm not sure if I had ozone on the next one. Yeah, so there is some disbenefit from ozone, but as I think the next slide shows, yeah, if I have them combined. Yeah, in general, once you combine these two effects, the benefits are overwhelmingly positive and, happen throughout the state. And in general, when we kind of sum this up across all of the, across the entire state and all of the effects, what we find is that for this, again, this is projecting quite far out into the future, but looking at this 2050 scenario, we find that there's the electrification scenario in general and all of the benefits that we found. We have about 12,000 fewer mortalities per year due to this scenario. And in terms of a monetized benefit, this is about $108 billion per year in benefits. And I always think it's worth noting in this that there's, the focus of this is on mortality because it's basically, let's say easier to quantify. It's you have a defined effect that is easily measurable. There's a lot of other effects from these air quality or from the pollutant concentrations that are that don't cause death but are quite bad. For instance, asthma, missed days of work. There's a large number of effects that can be quantified but weren't quantified for this. So this is in terms of the the quantification that is done in general for quality benefits. This is essentially a lower bound for the benefits from this scenario. In terms of the effects on environmental justice communities, what we did in order to kind of tease out what the effects would be, we looked at the environmental or the disadvantaged census tracts within Cal EnviroScreen 3.0 and focused just on these areas. And what we did is we looked, within those census tracts, we looked at what population was within those census tracts and what fraction of the benefits from each of these, pollutant concentrations was experienced within those census tracts. We found that about 25% of the population was within the census, one of these census tracts. But and those tracks had about 20% of the ozone benefit, 29% of the PM 2.5 benefits, and given the higher effect of PM 2.5, the total was about a 29%, 28% disadvantage benefit from the overall scenario. As I mentioned, that this is, I would argue that given all of the assumptions and everything in the study, this is a relatively crude approximation, but what we were really focusing on here is making sure that it isn't necessarily that the benefits are higher within the disadvantaged communities. It's making sure that let's say the benefits aren't focused on, I don't know, let's say Beverly Hills again to pick on them, but they aren't focused on areas that are already clean. They're focused on the areas that essentially need these benefits the most. In terms of thinking kind of expansively about the effects on environmental justice community, the report goes into more details on thinking about, let's say, making sure that job creation is focused within these communities, and recognizing that that the way that this calculation is done, has some weaknesses when thinking about environmental justice communities. But what I would expect from those results is generally that the benefits would be higher than this, but this is something that would need more study and quantification. So in terms of thinking about conclusions, I guess in some ways, with every study that you read, there's always kind of like this duh factor, which is basically, electrifying should help improve air quality, or does reduce emissions of these air quality pollutants, and hopefully produces benefits. I think that there's a couple of things when thinking about decarbonization, or starting from a decarbonization standpoint, that I think are important. One of them is that when we looked at the earlier aspects, this does result in significant decreases in emissions, particularly for some pollutants. But I didn't really go into detail on what we kind of didn't do. But electrification doesn't address a lot of things that can be important, like, for instance, solvents and road dust and things like this that that end up having significant health effects, but aren't really within the scope of, let's say, the energy sphere, and aren't really going to be addressed by decarbonization specifically. However, decarbonization has significant co-benefits, and so we should definitely be appreciative of that, and hopefully include them in thinking about quantification for how much, let's say, how worthwhile electrification is, or decarbonization is. An additional, I would say conclusion that I think really warrants further investigation is that focusing, let's say, electrification on houses that, or let's say residences in areas that currently use a lot of wood combustion, would have outsized impacts on health effects. And so, it's, as I mentioned, it's actually, we did try digging into this in more detail to basically say, okay, what percentage of households don't have any other way to heat besides wood combustion? And unfortunately, we basically just did not find a data source for this. So in terms of thinking about, how would you design a policy around this, or what specifically should be done, we don't really have answers from this study. But I think that we have a good indication that this is something that should be pursued for its wider benefits. And I have the report number up here again. That was all I had to present. I'm happy to kind of go back and go into more detail on some of the kind of subtleties, but I figured that we'd spend more, as much time as possible on questions if people have them.
Great. Thank you, Marcus. This is Panama with the Building Decarbonization Coalition again. Thank you very much for the presentation. Fascinating stuff. I think clearly shows that electrification is going to be a critical solution to some of our air quality issues. As you said, solvents and road dust and other areas are going to be hard ones to get down. I mean, I don't know how you eliminate dirt But and so we need to be looking at those areas we can eliminate, and we clearly, with a building electrification, have a very cost-effective, relatively easy to implement set of technologies right there. If we can just get some of the policy and market barriers out of the way, and so we need to be chipping down these problems as much as we can. And it's going to be easier to put in heat pump hot water heaters than to get rid of dirt in Southern California, I think. So we have a few questions that I'll read them out to you. The first one is the disaggregated data by sector available, publicly available? Like, can people find that somewhere, or is it in the study anywhere?
It's in the report to some degree, but probably not not at the level you're looking for. But I didn't put my email in here. But if you email me, I'll try to address that directly.
Okay. Do you want to just slowly say your email? Do you want to slowly say your email, Marcus, for everybody?
Oh, yes. So M. Alexand, or let's say M. Alexander, ALEXANDER at EPRI.com.
Great, thank you.
See if I can edit this right now.
Okay, and then another question was, perfect. Did you isolate the benefits of building electrification relative to the other major categories of emissions? And for everybody, if you want to ask any questions to Marcus, please feel free to do so via the chat feature. Just type in your question and I'll read them out to you. So did you isolate the benefits of building electrification relative to the other major categories of emissions?
Yes, we do have that. That also wasn't published, but yeah, we do have that. And actually, it's in the report, I believe. It ends up being a significant fraction of the total because, as I mentioned, PM 2.5 has a kind of outsized health impact, and building decarbonization, or let's say, particularly this residential wood combustion aspect affected the PM 2.5 emissions or inventory.
Great, wonderful. Well, I think that's the questions that we have for Marcus. I want to thank all the attendees and also Marcus for presenting a great study. This is going to be one of the key areas of focus for the building decarbonization community moving forward, is really health benefits of electrification of our building stock. And so I think this is going to be one of those key studies that we're constantly going back to prove our point and to really push policymakers in this area. So thank you all for joining in. As I said, we have great webinars coming up on August 8th. We have the Builders Needs Assessment, that's New Construction Home Builders Needs Assessment, their views on electrification. On August 15th, we have a comparison between induction cooking, electrical resistance cooking, and gas cooking performance. And then on September, on September 8th, we have the new offerings from A.O. Smith on small commercial heat pump water heaters. So please join us for that. Look out for the registration. Thank you all for joining the Building Decarbonization Coalition Presents webinar series. And everybody have a great rest of your Thursday. And we're ending the meeting now. Thank you, Marcus.